Hello, my name is Taher and I'm from Princess Sumaya University for Technology. Today I'm going to solve a problem on microwave engineering course about constant gain circuits and matching for maximum power transfer. Here is the question. You want to plot the 2, 1, 0, minus 1 dB input and output constant gain circles for gallium arsenide MOSFET with the following S parameters. S11 equal 0.707 with angle minus 155. S12 equals 0. S21 5 with 180 phase. S22 equal 0.51 angle minus 20. Then we want to find the load impedance for maximum power gain and source impedance for maximum output power. Okay, when we put this equation, the gain at the source max equal 1 over 1 minus S11 squared. So we have 2 in numerical value. In dB we have 3 dB. The gain at the load max equal 1 over 1 minus S22 squared. We have 1.35 and 1.3 in dB. G naught is the gain of the transistor. Depending on S21, we multiply by S21, and this means S21 squared equal 5 squared. We have 25 and 14 dB. The total gain equal 3 plus 1.3 plus 14, so we have 18.3 dB. This is the maximum total gain we have from this transistor. So we want to substitute the S parameters on the microwave equation solver. We have 0.707 with minus 155, 0 here, 0 phase, 5 for S21, 180, S22 0.51 minus 20. So we generate constant gain circles. We have here 3 dB and 1.3 at the load. So as we can see, we have a small radius here and a small radius here. So it's a point with 0.7 center and phase 155. So we want to go to Kitab and import the Smith chart and start to draw a line to 155 from the origin. Okay, the pen and like this. At the load we have 20 degrees, so we put another line here. Then we take the compass and open it to 0.7 for the load circuit, and we want to make a bow. So this is the intersection between this line and the center. So we here have the center. So this is a point which have a 3 dB gain. Then we have the compass and we put it at the center and open it to 0.5. We put it here and we draw another bow. So this intersection is a point. Okay, this point is 1.3 dB. So I want to continue with the source, then I will move to the load and make the matching. So at the load we have 1.3 dB as a maximum gain. At the source we have a 3 dB maximum gain, so we want to draw the circle of the 2 dB. 2 dB, we have a circle with radius 0.25 and at a center 0.62. We have the compass here, put it on this scale, make it to 0.62 and go up and make the bow. After that we click the compass here and open it to 0.25. Then we draw the circle and this is the 2 dB circle. Okay, then we put 1 dB. We have another circle on radius 0.37 and magnitude 0.54. We take the compass, put it here to 0.54. Put it here and make another bow. Then we want to make the radius of this circle 0.37. Okay, put it here and draw the circle. So this is the 1 dB circle, as we can see. After that we want to create the 0 dB constant gain circle with radius 0.47 at the center 0.47. We take the compass, we put it here and open it to 0.47. Put it at the origin. Then we make a bow. The same radius is here and we draw the circle. So this is the 0 dB circle. The 0 dB circle means that we have no gain here. This is the match point intersection with the circle. This circle is having a 0 dB gain. So after that we want to go to the load. So we put at the load, if we put 2 dB, we don't have a radius. So we want to put a smaller number like 1 dB. At 1 dB we have a 0.19 radius and the center at 0.48. So we put the compass at this center and put it on 0.48. Okay, I'll put it here. Then we intersect with this line. Okay, and the radius is 0.19. The center and put it at 0.19. Put it here and draw the circle. The circle 1 dB circle. Again we put 0 dB here. We have another circle which intersect with the origin. It's the 0 dB, 0.4 and 0.4 center. Put it here and then move it and draw the bow with the same radius. You put here and draw the circle. Okay, that's great. I want to label it 0 dB here, as we can see. After that, we want to plot the -1 dB circle for the source and the load. Let's see. Let's put here -1. Let's put here -1 and generate the constant gain circle. Here is what we get: 0.55 radius and the center at 0.4, and here we have 0.5 radius and the center 0.3 with the same phase. So we start with the source 0.4 and radius 0.55. You put it here, 0.4, we draw the bow, and then we took it to the radius radius 0.55. We draw the circle here. It's the biggest circle, as we can see, with -1 dB. For the load, we put the center here and we get 0.33 and radius 0.53. This is 0.33. We have it here. And we draw the bow and we put the center 0.53 and we draw the circle. Okay, this is -1 dB. So, as we can see, if we go decreasing the dBs, we have a bigger and bigger circles. Okay, let's now make the matching. So, we want to take the 3 dB point at the source and make it matching to this point. Okay, this is the 3 dB point. We want to find where is it. The 3 dB point is at 0.19 in the resistance lines, and as we can see, it's J 0.21. Here it's J 0.21. So I will label it this point with another color. I will put it Z1. So this is Z1, and I want to go to a point which is a constant resistance circle but with J 0.4 according to the conductance circle. Okay, let's put the conductance circle. This is the conductance circle. And we have another circle which is the resistive circle here. Okay, 1 minute. I want to make something and get back. Okay, I will continue now. After that, we want to go from this point to this point here. Okay, this point I will label it as Z2. This is Z2. So I want to go in this direction to get here and then go from here to this point, which is ZM, or we can call it YM. Okay, when we go at Z1 to Z2, we have Z2 minus Z1, which is equal to J 0.4 minus J 0.21, which is equal to J 0.19. This is J omega L, which have a series inductor. We have series inductor because we move clockwise and on the red lines. This is the red lines, and we move clockwise. And here we want to go from this point to this point. We move again on clockwise. This means we want to add here we want to add a parallel capacitor because we move on the blue lines here. So as we can see here, we have y2 equal to 1 minus j2, which is this point but in the conductance form. Okay, and okay, I'm sorry, make it here. So we have ym equal 1 plus j0. 1 minus j0 is the point which will be matched here. Okay, so as we can see, the match point is j0 minus j 1.4. We have minus j 1.4, which is a series capacitor. This is how we get the load matched. So okay, no, we have this parallel capacitor j0 plus j2 equal j2. So we have a source matched here. But on the load, we go and check this. We want to move from this point to a point which intersect here. This point, I will call it YB. Okay, I will call it YB, and this is the 1.3. I will call it YA. This is YA. So I will move from here to here. This means I want to move anti-clockwise on a blue line. So we have a parallel inductor. As we can see here, YB minus YA equal minus J 0.48 plus J 0.18. So we have a parallel conductor with magnitude minus J 0.3. Okay, then we want to move on this line, which is a red line, to ZM. So I want to move from this point to this point, which means anti-clockwise and on the red line. So we have a capacitor in series. So this means ZC equal 1.4, and Zm, the matched point, we have 1 plus J0. So Zm minus Zc equal J0 minus J 1.4. We have minus J 1.4 series capacitor. This is how we make the load matched. So I hope that you understand what I mean here. So that's all the story. Hope you understand, and thank you for watching. Bye bye.